Right, folks, it's time for the sound. Let's get it started today. Welcome, everyone. Welcome to this live recording of ThursdAI, the Twitter space, podcast, and newsletter that brings you everything that happened in the AI world every Thursday, literally almost every Thursday. My name is Alex Volkov. I'm an AI evangelist with weights and biases, and this is ThursdAI. All right, recap. Here we go. Taking a deep breath. We've talked about incredible amount of stuff here on ThursdAI for January 24th. We've talked about the areas of open source LLMs was very interesting. We've talked about Stability AI releasing a stable LM, tiny version, 1.6 billion parameters. It's really good at different languages, the European languages as well. And it's not commercially viable for open source, but it is under the Stability membership. So if you have, that's a great model for you. We've talked about Intern LM2 for a state-of-the-art on math LLMs. We briefly mentioned this, but it's getting 90% of GPT-4 performance on math, which was quite incredible. We also had the pleasure of Tanishq Abraham to join us from MedArc for the analysis of open source models as it relates to the medical field. And it turns out that the model called Quen72 from Alibaba, Quen72 is the best open source doctor that we have, achieving like incredible and beating even MedPalm 1, which was back then by Google trained as one of the best medical LLMs. We also were a very multimodal heavy space today, like a lot. We had we had the folks from Prometheus lab join us and talk about their multimodality, which is transformer based but not LLM based. So their multimodality is EEG signals and fMRI signals as they work on hyper-focused ultrasound to induce a lucid dream state in your brain. Their multimodal model is basically taking inputs from EEG and outputs in the directions or where to focus this ultrasound. Is super cool, and I definitely advise you to listen to them. It wasn't planned. I just saw them post. I just commented, hey, we're going to talk about this. They jumped on. Prometheus looks like a cool multimodal attempt. Nothing to do with vision. But also we talked about vision multimodality as well. So we've covered Adept, the company who was founded by a few folks from the original Transformers paper. And they have previously released persimmon models. And then Fuyu 8B was a multimodal that did not use a vision encoder, like a different architecture. They released an announcement. They didn't release any code or weights or the way for us to try this yet, but they released something called Fuyu Heavy, or they announced something called Fuyu Heavy, which is an extension of the previously released Fuyu 8B, significantly more trained. And they talked about how difficult it is to train multimodal models. And they claim to have a third place in the world after GPT-4 and Gemini Ultra on a bunch of the multimodal metrics and evaluations like MMMU and MMLU. They also talked about the process, how difficult it is to train these models at scale. So cool from Adept, and we're waiting for some ways to test this. We also talked about Fire Lava, which is, if you remember, we've talked about Lava before multiple times. Lava is a open source way to train models in multimodal, and like Baklava from folks on stage here, Nissan and Pharrell, and Obsidian from LDJ, who's also on here, and also Moondream. Like all of the things we've talked about are based on Lava. Llama was not commercially permissive license because of the dataset. Fire Lava decided or released the first Lava model with commercial permissive license from Fireworks AI, and we also had quite an interesting chat with Vic, who is the author of Moondream1, which is a tiny 1.6 billion parameter vision language model, also on top of Lava, that has Phi1 as the foundational kind of brain, the LLM brain in it. The conversation with Vic was very interesting. So shout out Vic, thanks for coming up. Specifically because he also mentioned that Phi1, Microsoft, if you guys remember, Phi2 was MIT licensed back in December. It was a surprise to all of us. And apparently they went back and also changed the license on Phi1, which is super cool. And Vic told us that he saw this. So Moondream is a very capable, very tiny vision model that works quite well. Definitely worth listening to this conversation with Vic. We also announced in this week's Buzz category of ours, or segment of ours, about everything weights and biases, we announced a new course in our academy from Jason Liu, the author of the instructor library, and he has a course now that was released today called LLM Engineering Structured Outputs. And as Nissan pointed out, a bunch of the folks in open source are learning from these free YouTube videos, and definitely worth checking out Weights and Biases Academy, because there's a bunch of knowledge there and it's all for free. And just join and just register. It's super, super cool. And then we had an incredible honor again of having one of the authors of this paper, as always. I love when we discuss stuff and the authors of the stuff come to chat with us. So we had Tanishq, but also we had Alex Birch in the audience listening to us while he was working and sending us DMs from the new paper called Hourglass Diffusion High Resolution Image Synthesis. And this paper will be in the show notes. And Tanishq went through the kind of the in-depth of the problem it tries to solve. And they talked about integrating transformers and diffusion models previously to separate areas, and they haven't came up with the first one, but they definitely used a bunch of the techniques to optimize transformers into the diffusion world and create a pixel space high resolution image synthesis, which shows great promise going forward. Incredibly insightful conversation from Tanishq, definitely worth a listen. We also covered in this area, we covered Instant ID, which is a one shot or zero shot face transition into diffusion models. So you can upload one picture of yourself and get quite incredible results in image diffusion, or like generative images with your faces or your kids' faces, which is super cool. I haven't tried my cat. I don't know if it like works on cats' faces. I will try it out. We covered a state-of-the-art automatic speech recognition system that beats Whisper, or at least runs 30 times faster than Whisper on different tasks. We're going to add this to the show notes as well. And a little bit about deepfake audio, with 11 labs have a dubbing studio released, and some conversation about whether or not or how it already affects politics. And then the last thing we've covered is National Science Foundation, NSF, announces a new partnership from all major labs and government agencies around AI, and includes DoD and DOA, and includes OpenAI and Anthropic, includes open source folks like Hugging Face, and MetaAI is also participating in this, and also Weights and Biases is part of that huge partnership, governmental partnership. So I think this is all the stuff that we've covered in this space. We have quite a show for you today, and as always, there's no boring weeks in AI, is there? And some weeks start slow and then pick up. Some weeks start crazy from the get-go. If you remember, there's one week where one Friday had a bunch of releases. And this week we had a very full week, full of very cool innovations, but also exciting stuff. And then we have some authors of those stuff here with us today. And we're going to talk about a bunch of multimodality, which we've been talking about for a while. Obviously, the space started with the multimodal GPT-4, and then we just kicked it into high gear. I think that it's time to get started with our default segment. So for those who are new to ThursdAI, we usually segment this to 5 or 6 segments, the biggest one being open source LLMs. And then we have big companies, LLMs and APIs. So we usually cover the Google stuff and OpenAI stuff. Mistral has been here and there, been in the open source, now is in the big company as well. So it depends on what they release. That's where Mistral stuff falls. And then we talk about vision and video, which is basically where we cover the multimodality stuff. And that section is going to be I think the main one today. There's so much stuff. It's crazy. We also have this corner I call this week's buzz. I feel like I have to explain this. Maybe people don't get this dad joke that I put in there. Buzz as in bees, right? So bees, buzz. And Weights and Biases, the shorthand for Weights and Biases is WandB. Weights and Biases, WNB. And for a very funny reason, there is a mascot of ours that's a bee that's holding a wand, because it's WandB. And like this little joke has been prevalent like in many places. I think I haven't explained it yet. And so this week's buzz is actually the corner about everything that I've learned with Weights and Biases every week. And so this corner we're going to chat with Jason and announce some cool stuff. The next corner we have is voice and audio, which we usually have a bunch of stuff. We have VB from Hugging Face usually join us. He's like the AI audio person over there. There's not a lot of voice and audio stuff, so I actually don't have anything voice and audio related in my notes. However, if you guys know like very cool things that happened this week with voice and audio, please let me know. We're going to talk about them. We're going to move to AI, art, and diffusion in the next segment. We're going to talk about some cool things there. And then the last segment is like a free-for-all. It's tools and others. So I usually put agents in there. I usually put like super cool things. So I have two exciting things to talk about there. So this is usually the structure.
I do have.
Yeah, tell me.
There is one more thing there, and it's the W2V, the BERT speech encoder.
Ooh,
I think it's
all right.
it's from Meta, and it's supposed to be like 30 times faster than Whisper. So yeah, it's another very efficient automatic speech recognition ASR model. So I'll post it in the links too.
And I think also we had 11 labs announced like I had a tweet about actually ThursdAI content that I spoke in English obviously, and then I asked it to translate to Russian. We'll cover this. 11 labs has a dubbing studio. And then let's go to open source, folks. I think let's go to open source. Open source AI, let's get it started. All right, let's start with our open source segment here. And I think the first thing we should probably quickly mention is our dear friends at Stability AI, folks who've made a dent on the industry with Stable Diffusion, obviously. But they're training a bunch of other stuff. We've talked about multiple stuff they did. We've talked about the Stable Video Diffusion and like how open source lags behind closed source, but not by that much. And Stability released a new LLM, which they had a stable LLM before. I think, Nistan, have you used Stability stuff before? For the LLM stuff?
I have months ago, so I'm not up to date on it.
Yeah, so
I've used it on other co-reps and stuff.
Yeah, so they're not like, they haven't changed the industry in the LLM world as much as they have in the image diffusion world for sure. However, there's a big however. They're working on multiple fronts, and looks like I had a chance to actually chat with Imad for almost 20 minutes. Imad is this like very incredible person who knows a lot about a lot, and it's like the conversation there is like basically a stream of consciousness conversation, which I had no trouble in following up because we talk about everything here in ThursdAI. But the folks who were with me and talking to Imad, they looked at me and was like, how do you know all this? And I'm looking at Imad, I was like, how does Imad know this? That's what happens when you're on Stability. So they're training a bunch of different models. This week they gave us Stable LM, which is a tiny model, 1.6 billion parameters model. It's really, we've been saying this previously, it's really funny to say small LLM, right? If you expand the LLM abbreviation, it's like a small large language model, but this one is tiny. It runs super fast on multiple devices. I think their point is to actually like edge device running. So obviously we've covered multiple small LLMs before. We've covered Phi, if you remember Phi 1. We're going to talk about Phi with Vic in a second. We also talked about like Phi 2. I think there's like a few others. Stability released theirs. It's pretty good. It's pretty good. I was itching to play with this. They released a GGUF. Apparently, and I don't know if you knew this, but apparently Stability has their own .cpp, and their like GGUF file, which is like for those who are not following all the acronyms, GGUF is a quantized version of models. So apparently Stability has like stability.cpp is incompatible with llama.cpp. And so apparently LM Studio had to add a specific support for this, and they did. And so if you want to play with Stability AI Stable LM, now you can with LM Studio. And LM Studio, at least in my experience, gave me ridiculous performance. I got on this MacBook M3 Max, I got more than 130 tokens per second, which was like ridiculously fast. And the model was fairly capable for a small model. I was very impressed. So if you want to play with a small model or you want to do some stuff with this, Stability is definitely an interesting one. Supports in LM Studio. Yeah, go ahead.
Yeah, it's a 1.6B, and that means it's 1.6 gigs to run at 8-bit without losing much accuracy. However, that means that it has a lot more applications for tiny stuff, because then you can get that down to 800 megs and so on. So people did find some issues. Again, it's a tiny model, but they found issues with it being able to continue the conversation. However, for one-shot answers, it was extremely capable. So just keep that in mind when using it. It is probably right now the best model for that size. Just keep in mind if you're going to do something with it, don't expect much in terms of follow-up stuff. Just if you can do it in one shot, great, use that. And yeah, that's about all I have to say.
Yeah, and additional things that it punches above its weight on other languages. So if you folks remember when we talked about Mistral, for example, getting compared to OpenAI, Anthropic, etc., Mistral Medium, the model is like specifically for the European language, the German, Spanish, French, Italian, all those, it's significantly better. Stability is also playing in that market looks like for the smaller size. And so this tiny model beats the 5 versions of 3 billion parameters. So it beats models twice its size, even some 7 billion parameters, specifically for European languages. And if you remember, we've talked about MPT from Mosaic, was that? Yeah. So this model beats the Mosaic MPT 7B, which was probably back in May, was like the coolest like open source model. So that was 7 billion. This beats that on empty bench and everything. It's quite incredible. It beats Falcon 40B. It's really the speed. The reason why we bring you these models is not only, hey, use this one. Because Nielsen said, this one may not be exactly good for your commercial stuff. Also, it's not really commercially viable. There's a specific stability license that you have, stability membership, they call it. You have to apply for stability AI membership. And then based on the size of your business, you're able to use. They have to make money somehow. But we bring this to you also to show that how fast we're moving from a 30 billion parameter model to a 77 billion parameter model, and now to a 1.6 billion parameter model. That compresses like incredible amounts of trillions of like words from the human knowledge into just... Listen, do we say like this can go down to like less than a gig, right? If we quantize like super quick.
Yep. At
Incredible.
4-bit, it should be 800 megs. So we're getting to the point where they'll just fit in a Raspberry Pi Zero with 512 megs, and they'll be conversational and useful and even multimodal. So we're almost there.
Yeah. It's quite incredible. And then, okay, so this is stability stuff. Meanwhile, I'll say hi to a new guest of ours that I just saw on my timeline. What's up, Wes? How are you?
Hey guys, how are you?
Hey, welcome. Folks, maybe you saw my tweet, maybe didn't, as that I love planning for ThursdAI, but I also love breaking news. As I was planning, I was going through my feed, and thankfully, my Twitter feed is back at his own, like giving me the best AI stuff. And Wes, and I think your co-founder is also here, Eric? Yeah. Let me add you real quick. I didn't plan on this, folks. I just literally just like tagged and they came. The video that you guys posted came through my timeline, and I would love to go and give you a stage for a minute or two to explain what Prophetic is, because the transformer stuff that you discussed with the EEG and fMRI signals, I really dig. Could you summarize that video for us for a brief, like 2 sentences? That would be super cool, I think.
Yeah, so this has been something we've been working on for a while. It's really essentially a multimodal transformer model that is designed entirely for neural data. And so basically what we've done is we've built a data set of EEG and fMRI. And what we're designing is a neurosimulation device to basically induce lucid dreams. And so we built a data set on heightened prefrontal cortex activity. This is the neurocorrelate of lucid dreaming. And so we basically built a model where you prompt it with your current brain state. We have a set of sensors on the device, and then we output targets for the neurosimulation.
That's quite incredible. So for folks in the audience, we talk about multimodality often, and oftentimes we just mean VLMs, like we mean like vision and text, which we're going to cover like a bunch today. But today, I think the highlight of today's ThursdAI is multimodality applies to many things. So you guys are, your multimodality is not even, there's no text in there at all, right? This is just EEG signals and fMRI signals, is that correct?
Yeah, it's purely prompted with EEG. And one thing I'll say is everyone talks about multimodal. And so you're using, let's say, an LLM, and you're prompting it with a photo, for example. This is similar in many ways, because neural imaging data, particularly EEGs, you can get it into, it's a neural image, you can get it into an image format and then prompt the model that way. But then on the generation side of things, that's entirely, we use a pretty unique fMRI embedding process that we come up with ourselves. And ultimately, the idea there is that you take this heightened neural activity, and those are candidates for targets for neurosimulation. And we use this technique called focus ultra.
What do you mean by targets for folks who have no idea what this means?
Yes, we're using, this is like the other big technology that makes all this work is focus ultrasound. Focus ultrasound, for those that don't know, is this really cutting edge neurosimulation technique that can get quite deep into the brain. Other techniques that people who may be familiar with direct current, alternating current really gets only to the surface of the brain, whereas focused ultrasound can get quite deep. But there's also this ability to steer the beam and also create acoustic holograms. And so when we think of heightened neural activity, it really takes the form of these 3D figures. And the idea being that we can create these outputs of fMRI targets and then translate those over to the focused ultrasound.
This multimodal transformer takes on the input EEG signals, and on the output, it prints out those targets. Those are targets for this technology to then stimulate the brain to go into a specific state.
Yes, and all of this is closed loop. So in that, once you create the simulation, the model's prompted again with the current brain state, and this is continuous process of learning and figuring out what sets of tokens lead to this heightened state. And that heightened state is really identified as gamma frequencies, and that's really the fastest band of activity. So it's this continuous process until someone gets to a lucid state.
That's quite incredible. So you guys announced the LLM today, but it's not like you're not releasing this open source. This is just an announcement of your efforts, correct? Anything else you want to add here? And I think you started talking about folks can join the beta if they want to.
Yeah, that's what I would point out is that we have a beta program that this is really the purpose of this announcement is we're looking for people to sign up. We've had 200 or so in the last 2 hours. And so this spring we'll have it working. And if you're New York based or you're willing to come out to New York, we'd be more than happy to have you test out the product.
That's awesome. Congrats, folks. Exo, you want to add anything?
Alex, hey, how's it going? This is Eric. I'm
Eric, yeah.
with Wes. Yeah, hi. Thanks for doing this. Yeah, one thing that's just, I think, the sequence of how we release these things, we showcased in October our prototype that we designed with Card 79, notably did Neuralink for Elon, and then also worked with Max Hodak at Science. Max Hodak, who used to run Neuralink for Elon and then spun out Science, so really top consumer BCI kind of design folks. And so then now we have this model, right, this ultrasonic transformer, where now we're going to be migrating that onto the technically working prototype and beginning neuromodulation. So that's what the beta user program is all about. We've got, like 225 people signing up for first 2 hours. We're excited to have people on board and begin to do this. You have an opportunity, especially if you're early up on that list, to be the first person to achieve an ultrasonically induced lucid dream, which, I think is going to be a pretty watershed moment.
That's super cool. I've tried to lucid dream a lot of times in my life, and I never actually got to a stable one. So I'm excited to follow you guys, but I'm also excited from the technology application of this, because we talk about transformers, and a lot of this is going to LLMs. Now this week we're gonna talk about transformers as applied to diffusion models as well. And here you are, like doing like full multimodality out of the left field. So I love it, and hopefully you guys will do some cool things and keep us up to date. And welcome to join on ThursdAI to talk about this.
Thanks, Alex.
Yeah.
Thank you, Alex.
Thanks for hopping on, folks. And as I love breaking news here on ThursdAI, this is like a tiny breaking news. Thank you, Wes. Thank you, Eric, for joining. Folks, if you want to try the future, sign up for the beta, because why not? And I think it feels like non-invasive, right? You put this headset on, and then hopefully you go to sleep, and hopefully you're able to control your dreams, which is like what Vision Pro will do for outside world, but this is like inside your dream. It's super cool. All right, let's move on to, I think we're moving on to the big, we're moving on to the big category for multimodality, as we're already here. Vision and video and multimodal, or at least a VLM multimodal. So I'm going to start with the big dog here, Adept. If you guys remember, Adept Labs were co-founded by a few folks from the original Transformer paper. I don't think they're no longer there, but I feel like I have to add this prefix every time I talk about Adept. Adept released a few models for us. If you guys remember, Persimmon was a 7B model, or 8B? 8B. It was weird, but they released an 8 billion parameter model. It was like very interesting back then. They also then, on top of this, released Fuyu, which is, persimmon is a type of fruit. Fuyu is the type of tree that persimmon grows on. So we see you, Adept. We see your jokes here. Also, I love the LLM naming. And then they released Fuyu back then, and Fuyu was interesting from the perspective of, it didn't use a vision encoder. It did something else. It was very interesting that their approach to vision models allowed them to use non-standard image sizes, because they didn't train it on such a thing. So back then, that was like what was interesting. And now they've announced, they haven't released anything. They haven't said, hey, here, use this. I wasn't even able to use this, but they announced Fuyu Heavy. Fuyu Heavy according to them. And so far, Adept have been trustworthy enough for us to trust what they say. This is the third in the world multimodal, or I guess VLM, so not multimodal like Wes and Eric just told us, but multimodal in the sense of like images plus text together. This is the third in the world model behind GPT-4 Vision and Gemini Ultra, which Gemini Ultra we haven't yet tried. Obviously, we don't have access. If you have access in the audience for Gemini Ultra and you want to help a brother out, let me try and play with this. Please let me know. But so they're announcing, Adept Fuyu is announcing that the Fuyu Heavy, their model, is 20 sizes smaller than GPT-4 Vision. I have no idea how they even know what size GPT-4 Vision is. They say that around 20 to 30 size smaller, and comes very close in the multimodality stuff. And they talk about the challenges of creating like large multimodal image-based model. The challenges are stemming from there's not a lot of datasets properly to test. There's not a lot of the tooling, instrumentation stuff are really hard for images as well. And so they announced this. They showed some very incredible performance. And I will remind folks that Adept specifically started with tools to make you run your computer. So their models are specifically tuned on UX, UI, and web stuff, and expecting to hear more from them and finally getting to play with this. Go ahead, Farrell.
Just want to say that demos are easy. I'm going to take it with a grain of salt until we actually see the model or are able to test it. Is that there's no indication of actual like speed of the inference or whether these examples were cherry picked or not, right? There's a lot of question marks about this, especially when you just come out and make a marketing announcement without actual access to the models. Yeah, it looks cool, but I'm not hyped just because it's not big. It's not verified or validated in any way.
Yeah, I'm with you. Specifically, I will say though about Adept specifically, we've seen stuff from them. We've seen papers from them before, and they did. Folks started asking like, "Hey, where's the weights? Where's the weights?" And they did say that stuff is coming, but they want to like keep a competitive edge. But we've seen like at least a new architecture from them, if you remember with Fuyu, and so we know that the Fuyu architecture is legit. Like they literally was able to create a multimodal without an image encoder or thing back then. We're definitely going to listen to this, but based on the metric that they released, if this actually performs as well on MMMU, which is the kind of the equivalent of MMLU for multimodal stuff, it's going to be very exciting. Their heavy model, definitely. Moving on, actually, Pharrell, I would love to hear what you think about this. And actually, Vic, this is dropping you off to the next conversation. Fireworks AI that I haven't actually used, but they released the first Lava model with commercial permissive license from Fireworks. So Lava was released. Lava, we've talked about, Lava is the architecture that allows many of these models to be trained in multimodal fashion, correct? Lava was released. It was not with a commercial license because it was trained on a bunch of, I want to say that wasn't marked for commercial and open source licensing. So a lot of these models that we get, we cannot actually use in production. And Fire Lava announced that like their first Lava model was commercially permissive licensing. And I think that's super cool because finally folks will be able to build this. And as a reminder, Llama, the LLM, was released without commercial license. And then Llama 2 released with commercial license. And then incredible amount of stuff started happening because companies who wanted to use this in production actually started like looking into this and using Llama 2. And so hopefully the same will start happening with Fire Lava. I actually am not sure if they released the weights. I think they did. Yes, they released the weights on Fireworks AI Fire Lava 13B on Hugging Face. And yeah, Nistan, go ahead. You guys trained stuff on top of Lava. So please, first of all, introduce the stuff that you've trained on and then also like comment on the ability to use this now in production.
Yeah, I just want to say that the entire vision, open source vision field and non-open source, it is extremely competitive right now. For example, here we've released Baklava, which is Baklava, again with the naming. So that was 3 months ago. Yeah. Also, LDJ here made the Obsidian, which is like the 3B one, and then they made a 7B as well. We also have the dev lead of Qwen. He was in the audience as well. So they made the Qwen 14B VL. And this part is Oh, and we have Vic as well, who also made a very fast and small model recently. And Baklava was being used as a benchmark, which was pretty interesting, actually. Yeah, the vision LLMs are extremely competitive right now. And I think it's one part where open source can really surpass what you get from any API, because it's something you can run local on the device and you have full control over. So the interesting thing, yeah, as for Fireworks 13B, that's still Llama 13B base as far as I saw. And I tried to use their inference on their site, but it wasn't working. And I can't complain too much about it because ours is not working either. That's why I was in AWS Gulag. But yeah, also to comment a little bit on Fuyu, because I do like they're trying a completely new approach. They don't use stuff that's similar to clip image models, which is what everybody else uses. They do something where they take, I think, groups of pixels or stuff. They serialize it. So the image is just being represented as just another string of text or a string of tokens. So they can scale to 8K, 16K, whatever you have. They don't have that limitation that others have in terms of architecture. So it is good to see that approach is working overall. Whether it will be competitive, we'll see. So yeah, I wanted to comment on that. But yeah, I haven't actually tried the Fireworks model itself, but I did see, again, the architecture is similar to also Lava 13B. Yeah, that's about all the comments I have on that.
And like you said, interesting that it's still based on Llama, right? And it's time for new things. And I think this takes us to the next topic of conversation. And again, Vic, I want to introduce you properly this time, or at least let you introduce yourself. But the next kind of iteration of our conversation about multimodality, like we said, today is a multimodal space, is the existence of like very tiny vision models, vision large language models, or large multimodal model. It's really hard to name these things. Vic, welcome to the space. This is your first time. Please introduce yourself, and then let's talk about Moondream a little bit.
Hey folks, hey Alex, thanks for having me. Super excited. My name is Vic. I'm pretty new to the AI space. I think, like a lot of people, I got into it when the big stable diffusion moment happened. And I was like, yeah, this is what I need to spend my life working on. So went out, bought a workstation with 3090 and started playing around with stuff.
You and me both, brother. You and me both. And okay, so the reason why you're here and the reason why I'm calling on you in the vision video area is because of Moondream1. Can you introduce Moondream1 a little bit to the audience?
Yeah, it's a small language model. It's about 1.6 billion parameters. It's built on top of Siglip from Google or DeepMind. I forget which one of the two. Trained by Beard as a vision encoder, and it uses Phi 1.5 as the text model. And then it's trained using the standard Lava dataset. So super thankful for the folks who worked on these projects. Amazing models that they've put together. It works. I'm tooting my own horn a little bit here, but it's surprising. I see people post screenshots of them asking questions, and it still blows my mind that it works that well.
Let me toot the horn a little bit because I definitely tried it out. Thank you for the Hugging Face space that you put up like super quick. And the next follow-up is going to be about how to actually use this. But this is based on Lava, so the same non-commercial license, correct?
Correct.
Yeah.
The top piece of feedback I've gotten from people is that they want to see this with a commercially permissive license. I'm working on that. The Fire Lava folks didn't release the dataset, but thankfully they did talk about their process to create the non-encumbered version of the dataset. So I'm working on it. I'll have that out in a couple of days, the dataset at least, and then we can start training models that aren't encumbered like that.
Incredible. And so the next thing that I wanted to talk to you about is Phi 1. So Phi is from Microsoft. Phi 1 was not released with commercial license. We remember it was trained on synthetic data and tiny stories, like a tiny 1.6 model. So we saw a few releases since then. So obviously we talked just now about stable LM, semi-commercial if you're part of their membership. And also Phi 2 was MIT license. It's a little bit bigger. It's 3 billion parameters. Have you tried with Phi 2? And could you speak about that experience?
Yeah, I did actually. So I was initially working on training Moondream1 with Phi 2 once it came out. There are some issues with fine-tuning it when you have flash attention on, I believe. And so it just takes a lot longer to train. So I went back and looked at Phi 1.5, and I saw that they updated the license for 1.5 to MIT as well.
Oh,
and so I
really?
figured I'd just stick with what works. Yeah.
Wow. I did not know this. So it actually updated the license backwards?
Yeah, on the Hugging Face page, at least, it says MIT now.
I love it. Like, it would make sense, right? But folks, I don't think we've talked about this. So, like, breaking news here. Thanks, Vic. Phi 1 is also, we'll check this. We'll double check.
Also 3. They're both MIT licensed now. So whatever pressure we put on Microsoft's Azure side, it worked.
Nice. That's incredible. All right, so now, so this part of your stack of Moonbeam is now MIT licensed. So Lava is the only thing that's holding this back from being used in commercial
Just the
settings,
data
right?
set, yeah.
The data set. Okay. So definitely there's work being done there. I will just send folks' attention to the nest, to the top of the space, where I had my tests. I literally just pasted an image. And again, thank you for the demo, Vic. Folks will get the demo in show notes as well. I pasted an image of 2 of my friends just sitting and talking across like a TV with some things. Literally, the model said, image features 2 men sitting in chairs, engaging in conversation. 1 man is sitting on the left side, 1 other on the right side. That's obvious, but still cool. They're both looking at a laptop placed on the table in front of them. The laptop is open and displaying a presentation possibly related to their discussion. So this feels like hallucination a little bit because the model does not know what it displays, but fine. And says, in the background, there's a TV mounted on the wall. A cup that can be placed on a surface nearby. The scene suggests a casual collaborative environment. This is ridiculous. This is like a super tiny model, and it outputs this scene almost perfectly. And I've tested like the same image in different like bigger GPT-4. It pretty much gives me the same information. So I was really impressed. So tooting the horn for sure, because the tinier the model is, the better the utilization. And we've talked about different vision-enabled hardwares that are possible or not possible based on whether or not they're going to be able to run stuff on like Raspberry Pi. And the smaller these models, the smarter they are, the better we'd be able to use them in cheaper hardware. Really impressive. What are you planning to do with this? Like, how's the community accepted this? What type of conversations did you get into, and what are you planning to do next year? Besides training the...
I was blown away by the reception to this. When I put it up, I thought like it might get like 100 likes or something, and then I'll move on to my next project. But I've seen a bunch of super cool demos come out of this. I think the fact that it is small and it runs inference so fast makes a lot of use cases that were previously not possible a lot more viable, like captioning a video in real time or recaptioning a billion images and whatnot. There's a couple of things I'm working on. Obviously, the top thing is like getting it to a permissive license. I could use some help on a couple of fronts. So I do want to make it easier to run, get GGUFs into Llama integration and whatnot.
Definitely LM Studio integration. I would love to play around with
100%.
this with LM Studio just to see how fast this runs on my software. MLX would be a cool suggestion as well. The community is very excited about MLX. I don't know if you saw, but LM Studio is a friend of the pod. Definitely, let's connect to you too. I think it's super easy to just add it there. Right, Nistan? It's not difficult.
You just got to add a JSON file to your model, and that's it. Or just message him because he's very responsive to this stuff and might even write the JSON for you. And then it will be immediately available for everyone running LM Studio.
Amazing. Another thing we have going on, by the way, is we're building an agent version of this with Open Interpreter in mind. A version of this that's excellent at identifying UI elements, because we want Open Interpreter to have the ability to operate purely off of a local model. Open Interpreter, by the way, a super cool project. Check it out, folks, if you haven't already, is a way to have the LLM use your computer. So you can do stuff like just tell the LLM, hey, I want to turn dark mode on, and it'll figure out what buttons to click to enable that, for example.
For folks who follow ThursdAI closely, they remember Killian came on the pod like a week after Open Interpreter was released, and this was, I think, in 2023, our most famous or received episode back then. It was a super cool conversation. So shout out Killian, Lucas, and definitely Open Interpreter since then has been very huge community of people building very cool things. Recently released the kind of the browsing area where it controls the computer for you, and it definitely needs eyes for that. And so I think it used GPT-4 vision, and now Vic, you're saying that Open Interpreter will get open source eyes. Is that what I'm hearing?
Exactly. That's a goal. Cog Agent is super promising in this space. They didn't release their data sets, so we're working on replicating that. Cog Agent is just too big for most people around their computers. It's forget, 17 billion parameters or something.
Is that Cog Agent and Cog VLM, right? I think I think we talked about this. Yeah, it's really good.
But yeah, that's another place where if folks want to get involved. The link in my bio has a Discord. I would love to collaborate with folks on getting that data set together, training that version of the model.
So I think the thing I'm hearing from Fuyu, from you as well, the data set for vision stuff are the bottleneck to create like incredible things, right? Like data sets for images, data sets for how people use UIs, for example. Like all these data sets are the the bottleneck for us to get to the next hurdle of getting these models even smaller, even faster performing. So what are we doing, folks? Let's start building multimodal data sets.
Yeah, and at first for Baklava, we were going to have the data set also open source because the code for us is also open source as well. So it's not just open weight, it is fully open. However, the data we couldn't because of the licensing issues. So it's not available. And yeah, it's pretty hard to make data sets for vision because with text is very easy now to manipulate, modify, do whatever you want to the data. And you can do that at large scale. But with images, just aren't that many tools, that many ready-to-go data sets. And the open source models just started getting good at them. So yeah, that's going to remain a challenge for the time being. But again, if anybody here is like a grad student or you're at a company or something in academia, the biggest contribution you can make probably is in the data sets because the models will get replaced. We'll always have better models coming and going. But the data sets are forever. If you want to make an impact in this field, get your professor, university, whatever, to put some money for data sets. We need data. We need data sets for images, with images. Yeah.
And we need them like bigger and bigger, ever increasingly bigger scale. All right, Vic, so thank you so much for joining us. Thank you for taking us through how you created Moonbeam. And thanks for telling us like what's next, how the community can help besides just data sets providing and testing. What else would you need?
I have a list of issues on GitHub where I'm looking for help with various tasks. But besides that, compute always helps. I'm currently limited on how many things I can do because my 4090s can only do so many matrix multiplications at a given time. So if anyone has compute that they can give me access to run these, that would be super appreciated.
Yes, I've seen this time and time again on ThursdAI on stage. Folks ask for sponsorship for compute. I'm actually getting like DMs from different companies like, hey, Alex, the space is super cool. Can we sponsor someone? Can we? And I'm like, no, I already work with Weights and Basses. I don't need sponsorship. I would want to connect guys that work on super cool things who need compute to keep going with different companies around like compute specifically. So Vic, I'll definitely keep you in mind. And go ahead, Nissan. You have a thing you want to say?
Yeah, just really quickly. This is a very effective way to make projects that are impactful. For example, with Baklava, Pharrell here, and Semtex, they just put out a README and tweeted something out, and we got compute, and we got it from Together Computer. So they sponsored that project, and they ended up being a very impactful project that a lot of people use. That works pretty well. I just say be careful with conditional stuff. Like if they're gonna start talking about an NDA, just ignore them because that's not really. Then you're doing an exchange.
Advice, yeah.
You're basically doing work for that person. So that's just a job contract. That's not a sponsor. If someone's sponsoring an open source model, there should not be like an NDA. That's no longer a sponsorship.
Better be open source after that. Yes, absolutely. Yeah. So Vic, I'll keep you in mind when people reach out to me. The folks in the audience, if you work at a company that wants to be featured forever in the open source community, definitely reach out to Vic. And we want more of this. We want more of like tiny models that perform incredibly well. We want them to be built into different tools that we can all use without relying or paying by just using our machines. So definitely we'll keep in mind. Vic, welcome, and welcome to the community of ThursdAI. More than welcome to keep joining and participating in this. I think it's time for us to move on, folks. It's been around 40 minutes. I think we're actually good on time. I think it's time for us to move on to this week's buzz. I wish I had. I really want to do like a music transition here for this week's buzz with like bees buzzing, etc. But maybe for next week. Let me just play the regular music and then we'll transition and talk with Jason a little bit. welcome to this week's Buzz, where I talk about some cool things that happened or I learned in Weights and Biases. Weights and Biases is, that was an abrupt music stop. Weights and Biases is the system of record for all your LM needs. So pretty much like most of the folks up on stage who train models use Weights and Biases. It's incredible. The ubiquity or Weights and Biases is pretty much prevalent everywhere. I just saw Stablequan, one of our friends of the pod, just trained something and just post like Weights and Biases, like a snapshot of his loss curve going down, and literally just asked, hey, do you mind putting a link to the dashboard? And he did. So if you want to check out how his model is going, I think he's training, I don't know if you guys saw, he's training something like super cool, like he's training a mixtural for 400 million parameters. So he's training like a tiny MOE of mixtural. Stablequan he just posted like a chart with the train loss from Weights and Biases. And I just asked, hey, can we follow along with the training? And he posted a link to the Weights and Biases dashboard, which is super cool, which got a reaction from Weights and Biases CEO. And so I love seeing this in the wild. So folks, if you're training models, please put those dashboards up so people can follow along. It's really nice. But on the other news from Weights and Biases this week, I want to say hi to Jason Liu.
Yep, Jason Liu.
Jason Liu, welcome, Jason. I've seen you around. I've seen you, I think, at AI Engineer event from Swix. I don't know if we ran into each other there, but you had a talk there as well.
Yeah, it was Pydantic is all you need. It did pretty well on YouTube, so I'm pretty happy about that.
It did great. I also talked with a bunch of people. I think I was interviewing folks outside of the stage while we were giving the talk, but then it was very well received. And this is on the similar topic that we're going to talk about now. So please feel free to introduce yourself briefly, and then we're going to talk about the stuff that we did together.
Great. Yeah. So I'm Jason. In the past year and a half, I've been mostly doing a lot of applied AI consulting. Before that, I spent the past 8 years just doing machine learning. So I did the big data wave, the machine learning wave, the neural networks and deep learning wave, and now we get generative AI. So it's been a lot of fun. And in my spare time, I work on a library called Instructor. So now we have Instructor in I think JavaScript, Python, and Elixir. And the general idea is that we want to bring just functions and structs into LLMs and make LLMs feel a lot more backwards compatible with existing code rather than creating new abstractions to handle some of these things. And I think that's been pretty well received in the community.
Absolutely. So Instructor is definitely where I know you from. And today we have an announcement together. So feel free to announce the cool thing that we did and that you worked on really hard.
Yeah, so we're starting a new series around the idea of using schemas and structures to prompt language models. And I think end of the day or end of this week, we're going to release the first part of a LLM engineering series. And the first part really is just an introduction on how we can use things like structure to prompt LLMs a lot better, right? In the past, we just beg for the language model to give us JSON. Now we have things like JSON mode and function calling and tools, which gives us the ability to get more structure. But we still need a lot more tools and ways of thinking about how we can reason about these structures. And so part one is going to be around justifying and motivating why we might want to do this. And then I think in February or March, we'll start working on part two that uses a lot of the new Weights and Biases observability tools to look at how I've solved a lot of LLM problems in production with a lot of my consulting clients.
So just to highlight for folks, Weights and Biases has a free courses area, Weights and Biases Academy, and some very prominent folks in the industry have collaborated with Weights and Biases to just basically teach you for free how to do these things. So we have courses from training LLM from scratch, fine tuning, etc. And then Jason is announcing a new course today that he wrote and recorded, and we helped edit a little bit and publish, and also obviously talk and promote this a little bit about how to actually ask your model to give you what you need as a developer, as an AI developer, in a structured output, which uses the Instructor library, correct, Jason?
Yeah. These ideas can be used in other libraries as well, right? So for the Python community, we're really using a library called Pydantic. And so this is supported in things like LangChain and Llama Index and Guardrails and Marvin. And so even if you don't use a library like Instructor, learning how to think about prompting for structure is still something that's going to be really applicable and valuable for everyone listening.
And you mentioned before, there's a bunch of stuff that OpenAI comes up with, like JSON mode, in example, etc. They released functions back in June, but also the other LLMs, they don't necessarily follow the same kind of new abstractions that OpenAI releases. I think Anthropic just recently announced that they're moving to function system messages or moving to just messages things. And also we have open source, which is like all over the place. So I guess my question is, with these libraries, with these Pydantic approach and Instructor, would that apply to other LLMs? Does this apply to open source, which we talk a lot about?
Yeah, so right now there's only a few open source models that support function calling. So if you've looked at some of the work from the Functionary team, they have been training, I think, Mixtral now with function calling. Same with the guys at like News Research with Technium. There's been a lot of progress in the open source world in getting things like function calling. If you want more structured outputs too, there's a great library called Outlines that can use something like the Hugging Face Transformers library to also do structured extraction. And again, they also support things like Pydantic. And the goal of the course really is to show you how to think about and how to model these problems in a particular way.
Absolutely. And I think John Durbin in the audience, I think Ouroboros was trained on function calling as well, if I'm not mistaken, John. So folks who haven't heard our conversation with John, definitely go and check out. We had a deep dive with John about Bagel, which now includes the Ouroboros dataset, which now includes function calling as well. So that's awesome. The open source also moves there. Go ahead, Nistan.
Also, really quick, the News Vision model ended up being good at function calling, although it had other drawbacks. It was good at function calling because of the Ouroboros, like 1,000-something functions data set. And as far as I saw, the newer Bagel models, so Bagel 7B, are also good at function calling.
So Beagle model series from Maxime Le Bon. Again, shout out Maxime Le Bon, who came on the pod last week, and then the full deep dive with him will going to be released this Sunday. So make sure you're subscribed. We don't talk about function call. We talk about Neural Beagle. Neural Beagle is like one of the top performing 7 billion parameters. It's a merge. It's a cool conversation about merging. But let me get back to Jason just real quick. Jason, you're also like doing independent consulting. You said in multiple places, and you're like helping them build. I gotta like tap into your experience from like actually like hands-on AI building in companies. Could you give us like a little bit of what do companies struggle with, like with the first obvious thing that comes to mind that people like AI builders probably like already solved in their minds? What do you have to go through to not only build to them but also educate them on as you join the company and starts like helping them out with AI stuff?
Yeah, so one of the biggest things I notice is that when we look at something like a RAG application, really what it looks like is a recommendation system, right? If you went on Netflix, for example, when you watch a bunch of movies and the recommendations don't get better, it would be a really terrible experience and you probably lose a lot of customers. But for a lot of companies these days that are using things like agents or retrieval, we are in a situation where, no matter how many users you get, if you don't improve your language model, or if you don't improve your embeddings, the product doesn't really get any better. And so one of the big things I'm focusing on this year is helping these companies build a better feedback loop and a data flywheel. And so we can know for sure that as we get more users, there's these network effects that improve the models that we want to train. And so I think step one is being able to fine tune your own embedding models and your re-rankers and go from there and then see what comes up in the future.
Awesome. So definitely, folks, give Jason a follow. The course, I think we're releasing it today, but I haven't seen any social mentions, but it's really worth watching. I watched a few of this and we'll follow as well. And this is a course series now. So we're going to start with this and then we're going to continue with the monitoring tools that Weights and Biases have, correct?
Yeah, the first course is like 30 minutes. It's super quick. The real goal is to show you what's possible and get you thinking about some new ideas. And then the next course will be deeply integrated with the more observability tools from Weights and Biases and specifically around the experiences I've gotten from consulting production clients.
Incredible. Thank you, Jason. Thank you for joining us. And thank you for folks who worked on the course together with you. I'm excited to see this. And again, a reminder, there's a bunch of free stuff there. There's a bunch of like knowledge just drops here. And hopefully I will be able to tap into this community and also build more things. Go ahead, Nistan, and then we'll move on.
Yeah, I just want to say that a lot of us here that got good at machine learning were from just random YouTube series. So the Karpathy series on building one from scratch, the full stack is just pronounced like that, their LLM one from way back in April and March. So I'm really looking forward to this one because doing YouTube tutorials is actually extremely efficient. But on that note, we have breaking news.
Wait, we have breaking news. Hold up. You know what this means. AI breaking news coming at you only on ThursdAI. Yes, Nistan, go ahead now.
Phil Schmidt, who is a friend of the pod and has been here,
Yes.
the dev lead at Hugging Face. He's also the one that did the integrations. If I might be wrong, but the integrations with AWS Bedrock and
Cloud
also
AI,
with
yes.
Cloudflare workers. Yeah, so now it looks like he's been working on doing an integration with Google, where you'll be able to just take whatever models or fine tunes and stuff you have on Hugging Face, and then use Google's infrastructure, use both their TPUs and NVIDIA H100s. They're advertising this, that Google owns, to continue training, fine tuning, serving, deploying stuff via Hugging Face. This is a very interesting move. Google's jumping in more on the open source side there. I don't know what this means, but this is a very interesting development.
I know what this means. This means that if Hugging Face becomes public ever, buy their stock. That's what this means. Hugging Face like literally embedded into the infrastructure of AI, and definitely worth following. And the more integrations they have, the better like it is for the open source community as well. All right, folks. Thanks, Nistan, for
this
the
is
breaking
not
news.
financial.
Not financial advice, but they're also
advice.
not public yet. Like, I don't think this
Oh,
moves.
okay.
Yeah, I don't think this moves the needle for in terms of Google investing. All right, folks, we're moving forward, and where we're moving forward is also like into kind of like diffusion mode, and I'm very excited to introduce Tanishq. Tanishq, have you been here before? Remind me, please. I don't think you've been here on stage before.
I don't think I've been on stage before.
No,
No.
all right.
You
So
mean?
I'm very excited to have you here. Thank you for joining us. So, folks, one of the coolest things that came out in at least the research area from this week was this paper from multiple authors, some of them friends of the pod, like Enrico. If you remember the chat with Enrico we did with rope scaling, is on the paper as well. Catherine Crowson, who we should mention, I don't think she's been here, but we've talked about some stuff that she did. Stefan Baumann, Alex Birch, Tanishq, you're on there, Daniel Kaplan, and then Enrico, a friend of ours, Enrico. Tanishq has been the friend of the pod behind the scenes. You guys didn't know this, but we've met in Europe, so we met before. Tanishq, do you mind introducing yourself just briefly for the audience who haven't met you or followed you so far?
Yeah, sure. My name is Tanishq. I am a research director at ThursdAI and also CEO of MedArc, which is a medical AI research organization. I've also been involved with FastAI, been working on diffusion models for, I guess, past year and a half or so. Yeah, so I do all kinds of stuff, generative AI and medical AI. Yeah.
You also just like briefly skipped over the fact that you got your PhD at 19, right? Is that correct?
Yes, that's correct. That was last year. Yes.
So if folks in the audience don't know what this means, there's not many like 19-year-old PhDs, and Tanishq is one of them. And also we met once, I think a year and a half ago, and then the next time we met in Europe, Tanishq remembered every detail of our conversation. But that's beside the point.
Yes.
Yeah,
we met at the Stability AI launch event. That's
party.
where we met.
That was super cool. And
it was
since
pretty
then,
fun.
many things have changed. And I really want to talk to you in that area, right? So this paper, shout out to all the authors, because I'm looking at this. I've seen like multiple folks share this paper. Paper is talking about high resolution image synthesis with something called Hourglass Diffusion Transformers. And I will pin your great thread about this here on top of the space, and it will be in the show notes. Could you briefly tell us the problem this tries to solve, and then we're going to go into actually how this kind of approaches how to solve this?
Yeah, definitely. Yeah. So first, I'll of course preface this by saying this is mostly, of course, Kat's genius work here, and we were just lucky to be able to help her on this project.
Let's
but
just
yeah,
pause, just one tiny second, because it's worth shout out. So by Kat, you refer to Catherine Crowson, right? And if folks ever used Stable Diffusion before, either in automatic 111 or whatever, and you choose anything with K dash, this is the Catherine, right? This is K Diffusion is like her area. Very incredibly prolific person in this area. I don't know many facts about her, but like everybody who I talked to from this paper, including Enrico, everybody like referring to Kat. That's her work. So maybe a huge shout out to Kat. And yeah, go ahead, please.
Yeah. She was like one of the original AI art people. So yeah, she helped start the field in a way. Anyway, to provide some context of what this paper is about, the idea is that if you want to do like high resolution generation, so think like 1024 by 1024, the typical approaches these days utilize some sort of multi-stage approach. Like the most common one, like Stable Diffusion, is this sort of latent diffusion where you have to encode it in with some sort of autoencoder into some latent space, and you're doing diffusion on the latent space. and you're not actually doing it on the actual pixels. And so that comes with some disadvantages. For example, if I don't know, if people who are like doing things like image editing with stable diffusion, you realize that you don't have a whole lot of fine-grained level of control in terms of the actual at the pixel level. It's difficult to do that because it's happening in the latent space rather than at the pixel space. So there are various different things where like it has its own challenges. Of course, like latent diffusion has a lot of different advantages too, but for some applications it may not be ideal. And then on top of that, the other aspect that we wanted to like look into basically was the fact that we're seeing people move towards transformer models for diffusion as well. And of course, in the past, most of the diffusion models have been with a U-Net architecture, a convolutional U-Net. So stable diffusion uses a convolutional U-Net, but there have been a lot of papers examining the use of transformers. And of course, the nice thing about transformers is people know how to train them. They're quite scalable. So people would rather use transformers for diffusion over something like a U-Net. But again, the problem is that so far, it's mostly only been applied to the latent diffusion scenario, mainly because it would be very hard to do this at pixel scale because of the quadratic complexity of attention. So if you wanted to scale up to higher resolution, that it would be with the number of pixels, you're going to have quadratic scaling with that. So it would be very difficult to train this with, I guess, enough resources or whatever. So that's the problem that we're trying to solve is what can we do to resolve the quadratic complexity of the transformer architecture that allows us to then train a diffusion transformer in pixel space. So that's what the Hourglass Diffusion Transformer tries to address.
Thank you for the brief introduction. I will try to recap as a way I understand this, so folks who are not machine learning scientists in the audience would be able to follow along. But basically, Gen AI, this whole wave of Gen AI has two big infrastructures so far, right? The diffusion, the stability AI, and of the image models and video models, they're based on like diffusion, or you said latent diffusion, correct? And then there's the LLM area with basically based on transformers. And we've seen a bunch of stuff going back and forth in techniques between them, right? So LoRa, I think, is a thing that like many people in the diffusion area like trained LoRa's on different concepts, and then obviously like fine tuning with LoRa's then became a thing. And back and forth, we've seen like back and forth different approaches. Tanishq, you said like the open source area in LLMs, in transformers specifically, has a bunch of like super cool tricks and optimization techniques and flash attention, different things, right? There's like a bunch of stuff that people developed in one area that wasn't necessarily applicable to diffusion models. And so you guys set out to try and unify those two, or at least use some of the tricks, and succeeded to an extent. Yeah, go ahead, please.
Yeah, I think it's about now that we have this transformer architecture, we can try to apply some of the tricks that people have been using, things like rope embeddings. There are other tricks like RMS norm. These are the sorts of tricks, for example, that are using the llama architecture, these sort of similar architectural decisions. And you could take those sorts of best practices and try to see if they help with diffusion now. So yeah, I think that's the idea. And like people were exploring, that's like another interesting thing about our papers. Like people were exploring diffusion transformers, but they were using very kind of old architectures for diffusion transformers. And here we're trying to also apply all these tricks that we see people are applying in the LLM space and trying to apply that to diffusion. But yeah, that was also an important part of our paper as well.
And so of course you mentioned rope, and I want to shout out friend of the pod Enrico from News Research. Enrico, I don't actually remember if Enrico is part of News Research. Maybe so. He and News Research worked on the rope paper together. And for folks who are interested in hearing about rope, we had a deep dive during the summer, one of the coolest episodes. Most of it back then went above my head, but it was super cool going back there and say, hey, I learned this. Rope is basically a way to extend context windows and do a bunch of other things for transformer-based large language models. And I wonder, how does rope apply here? And Enrico is part of the authors here on the paper, so he contributed at least part of that work, I assume. Tanishq?
Yeah, I think the rope stuff is like something that we haven't like fully explored the full potential there, I think. But at least for what we were doing, we saw improvements in performance just using rope over other sorts of these sorts of position embeddings. But yeah, I think there's definitely potential for allowing the model to handle larger resolutions or do things like this because of the rope embeddings that we have in the model. But yeah, it's I think also meant for future work.
Incredible. You guys use all these techniques. You introduce, or I guess start formally announcing this concept of diffusion transformers, which is the mixture of these two things. And what are some of the results that you get? You've trained a few models to test. How do you even measure that you're getting performance? Are you just looking at algorithms? Are you actually generating images? Can you talk us through the process of like validating this, like theories and papers?
Yeah, but I just want to, I guess to take a step back to clarify, we didn't necessarily invent the concept of diffusion transformers. That is something that people have already developed. But the idea that we focus here is the problem is in the past, diffusion transformers were done with the latent space because of this quadratic complexity. So we basically have a different type of transformer architecture, which is this hourglass transformer that enables for like O of n scaling. So like a linear complexity. So it will scale with the number of pixels much better than it won't blow up like you have with the attention quadratic complexity. So that was the main trick that we're using. So we have some tricks in there that allow it to have that property. And that's what enables us to do it on the pixel space, as opposed to the latent space that the previous diffusion transformers were doing. And then on top of that, you're adding all these additional transformer tricks, which no one had tried out before with diffusion transformers. So those are the main sort of contributions of this paper. In terms of, and yeah, I guess one thing, the other thing worth mentioning is that the way that this architecture is able to do this is partly because the architecture is a very hierarchical architecture. So it's actually able to process at different image resolutions. And for example, at the high resolutions, we use a sort of this sort of local attention, which is what is having this linear scaling. But then at the low resolutions, we are able to do the regular attentions. Yeah, there's also this hierarchical processing of the image resolution. That's also, I think, an important point, which enables also for higher fidelity as for generation. And so, yeah, in terms of testing the architecture and things like this.
Like the next question is, how do you actually like test the architecture? How do you validate that these like approaches that you try actually better than what the field has previously been at?
Yeah, we looked at two data sets. One, we did generation, so class conditional image net generation. So that is passing in an image net class, you generate images of that class. So if you pass in a zebra class, you're generating zebras, or you're some sort of dog class, you generate the dogs. We train a model for that. We train it at a resolution of 256 by 256. And that's one of the experiments where we compare to other architectures. And so the interesting thing is that, of course, we're comparing to other architectures that are using, for example, latent diffusion, that they're using the latent space. The architecture is functioning on the latent space and not on the pixel space. But we have our architecture that's functioning on the pixel space and using this hourglass transformer, and it's getting better results than with the latent space. We're beating, for example, the previous diffusion transformer model, which was using the latent space. And then another interesting data set that we used was the FFHQ data set, which is this sort of data set of high resolution faces. And so this is at a 1024 by 1024 resolution. And so this is very difficult to be able to train, especially in a pixel space, at a scale of 1024 by 1024. And actually, there are not many other diffusion models that are trained on this model. There are a bunch of GAN models, for example, but not really many diffusion models. There's only one or two that we actually found in the literature, because it can be a bit difficult because of the pixel scale or the resolution of the images. But yeah, we managed to train a model with our architecture. It trains quite fast. And yeah, we're basically I guess at this point now, we would be the best diffusion model for that data set. And we are measuring with FID, but of course, FID as a metric also has its problems. It does have some bias towards GANs. And so GANs tend to have a lower FID kind of in terms of the bias of the FID. So when we look at it qualitatively, honestly, we think it's quite comparable to the GANs, might be better than the GANs, honestly. So we may do more evaluations and study that further. But honestly, this may be one of the state-of-the-art models for this FFHQ data set. But it's a bit hard, but using as a metric. But that's, of course, the problem with everyone's using that metric in the literature. But yeah, I think that, again, that's another really interesting result that we observed. And then, of course,
So,
we
Tanishq,
do.
I want to follow up with a question here real quick. For folks, like, hard for them to follow like much of this, but they've used something like Stable Diffusion
Oh,
before.
sorry.
But that's it's all great. This is all recorded. Folks can like pause and go to and go research and come back and listen to you. This is great. Like, you did the deep dive. I really appreciate it. I just want to bring this back a little bit upwards towards like, how
Sure.
does this affect the industry? Given that we have stuff like Stable Diffusion out and that keeps getting better. Midjourney is getting like reality adjacent to the point where like it's really hard to distinguish. There's like different upscalers that take the outputs and then run some upscaling. How does this affect the industry in your mind? Will this accelerate some stuff? Will this be applied to different areas that like diffusion models have not been traditionally in? What is the kind of the, let's say this is a building block that you've created. How does this affect us in 3-6 months?
Yeah, I think this is just a kind of a new, unique direction to explore. Of course, I think latent diffusion is still a very interesting and valuable direction, but this is just, it's always good to have different directions to explore. And I think, and honestly, like this architecture can be applied to latent diffusion as well. And maybe we get even better results. For example, we can do maybe like multi-megapixel level synthesis by combining this method with latent diffusion or something like this as well. So it's not even like it's limited to just the pixel space. That's what we're showing, that's something that is interesting about this. But again, it can also be applied to latent diffusion, and even, of course, these models could be scaled up further. There's a whole lot of future work to explore here, I think. And yeah, I think, and of course, it's computationally efficient. And yeah, I think the nice thing is, yeah, moving towards the transformer architecture when it's people understand the transformer architecture at this point. I think there's people understand how to scale it and different tricks. And I think this is a good, by introducing this architecture, this is a good way for us to try to bring some of those advances in transformers into the diffusion model field as well. So I think that's the other interesting aspect of this.
For me, reading this is not a machine learning scientist. Reading this was like the highlight of interesting things where like the open source community moves in different areas, but also like bringing over some of the learnings, bringing over some of the talent, the tooling around like making things available. And I think that's like very exciting. We also have Alex Birch, is that correct? The name also in the audience. So shout out Alex. And then what else did we not cover this thing? This is the last thing that you want to say, or maybe shout out some of the co-authors. Feel free, the stage is yours.
Yeah, I'm just looking at some comments that Alex also had some comments that he said. So he thinks, for example, that with this model that there's potential to achieve more realistic textures than even Midjourney. So I think we have observed, like with the model, like because that's the thing about when you're using a latent diffusion, where it's not, when you're not doing it at the pixel level, it's a bit difficult to get those textures accurately. But if you're doing it at the pixel level, I think you're able to get those textures. It can do that much better. And we've observed that with the models that we've been training. And so, yeah, I definitely agree with Alex there. Yeah, I think also like it may have potential to achieve like really realistic textures. And that's something that I guess we could look forward to, hopefully. But yeah.
That's incredible, because I think the realism comes from the imperfections, especially like textures and skin, etc. And like diffusion models have, at least for many folks, are easier identifiable by the kind of the smoothness of edges and different things. So definitely like more textures are there for humans in real pictures, and then we're looking forward to more of that in diffusion models. That's incredible. So definitely thank you for breaking this down for us, Tanishq. Thank you and Catherine and Alex and everybody else, Enrico, who worked on this. I think we have some questions from folks on stage here. Vic, go ahead, please.
Yeah, not a question. I just wanted to say, I played around with the repository a bit. It's a great way for anyone interested in getting into diffusion models to get started. It's not your typical research code base. It's super clean. You're not going to run into a bunch of dependency issues and whatnot. So that was just amazing. It's also super compute efficient, so you don't need to have compute to start to see good results. I strongly recommend checking it out if anyone was feeling intimidated before WandB.
Incredible.
Yeah, that comes down to Kat's genius. I think this is a code base that she's been working on for quite some time, and I also really enjoy working with it. It's like one of my favorite diffusion model code bases. So I definitely agree that anyone who's interested in playing around with diffusion models should check it out.
So that's on Kat's GitHub. We're going to add this in show notes, called K Diffusion, correct? It's now part
That's
of that
correct, yeah.
existing code base, but now like this, the Fusion Transformer. Get used to say Diffusion Transformers from now on, folks. Hourglass Diffusion Transformers, HDITs are now a thing. And Tanishq, thank you so much, and Alex for joining in from the comment area, and thank you for working on this work. Hopefully, this will get the recognition it deserves, and definitely as a foundational block to get us higher performant, lower hardware requirement models that look way better. Incredible. Tanishq, I wanted to follow up with you because MedArc is something that you're now CEO of medical things. And then you had a tweet today that I would really wanted to talk to you about, specifically because Quen was involved. And we have like folks from Quen, usually like friends of the pod as well. They join us. Could you, let's talk through this, please. Let's talk through how open source is catching up to medical space. Could you briefly summarize what we've talked, recent work from you guys?
Yeah, sure. Yeah, I've been quite busy with all kinds of different research projects. So that was another ongoing research project that we're working on at MedArc, and that I'm shared some progress of that today morning. So basically at MedArc, we're of course interested in developing open source medical language models. So that's something that we're heavily interested in. And of course, in order to be able to do that, we wanted to understand what the current capabilities of these language models look like, the open source language models. And no one had done like a very proper analysis of this as far as I could tell. And yeah, basically what we did is we added this suite of tasks known as the multi-med QA suite of tasks. So this is a kind of a bunch of tasks, a total of 9 tasks that they came from different other papers and stuff, but Google put them together as this is their sort of evaluation bench. This is the evaluation benchmark, that this is what Google was using to evaluate their MedPalm models and whatever models they had. And then the community, the medical AI community, been using that, been used to evaluate GPT-4 and all kinds of other models as well. And yeah, we at MedArc, we added it to the LM eval harness. So that's like the common sort of, for open source language models, everyone I think uses LM eval harness to evaluate the models on various tasks. So now it's in there so people can easily also evaluate their whatever models they have on these medical tasks. And so once we added it into LM eval harness, we just wanted to just do a comprehensive like analysis of a whole bunch of models in the open source space, just to see like these sorts of generalist models, like they're not necessarily particularly trained on medical data. And of course, we've probably seen some in their pre-training or whatever, but that's not their main purpose and that's not their main focus in their pre-training. And I was just curious what their performance would look like and how it compares to other models like GPT-4. GPT-4 is also a generalist. It's a generalist language model as well. It's not also necessarily trained on medical, but it's really good at that. In fact, prompt engineered GPT-4 is state of the art on this benchmark, actually.
I remember this. I remember where Google came up with a specific medical device, and then GPT-4 just like basically with prompt engineering on that benchmark became the top one, right? This was quite incredible.
Yes,
the most generic model we have. Yeah, go ahead, please.
It's called MedPrompt. That's the state of the art. This prompt engineered GPT-4. It's called MedPrompt, and so they do a whole bunch of tricks like dynamic few shot and GPT-4 written chain of thought and all kinds of tricks that they throw at GPT-4, and they got state of the art. And then of course they use the same tricks to then later claim that GPT-4 is better than Gemini as well. So it's not just for medicine that you can use it. They use it for just general prompt engineering as well. But yeah, anyway, so yeah, So overall, the point is I wanted to evaluate how these models do how the open source models do on this benchmark. And so I evaluated a whole bunch of models. I evaluated Llama, Mistral, Mixtral. I evaluated the Yi series of models. I evaluated Quen. Yeah, so I evaluated a whole bunch of models here. And basically what I found out is, first of all, Llama 2 is not that great compared to all these other models, actually. And it's interesting because in the literature, people are still fine-tuning Llama 2 for medical purposes, but it actually doesn't have a very good base capability for medical knowledge. So Llama 2 is not very good at medical stuff, but the models that are quite good are basically the Yi series of models. So Yi 34B is really good, as well as the Quen series of models. So Quen 72B is the state-of-the-art open source model. And this is not like doing any sort of prompt engineering or anything like this. This is just like 5-shot prompting, and it's beating MedPalm version 1. So MedPalm version 1 was released in November of 2022. And that was like the first sort of, that was Google's model that they had. And this Quen 72B is beating MedPalm 1 without any sort of prompt engineering or any of these tricks. And yeah, I think that's really honestly quite impressive because
that's quite incredible. Yes. I want
you
to
know,
shout out Jing Yang or Justin Lin, a friend of the pod, the head of technical work on Quen, for such like incredible achievement. And thank you for testing this, because and Nistan, like you worked on AI in medicine as well. Like we're waiting. This is going to happen, want it or not. There's like several doomers that say, hey, never trust an AI doctor, but many people already go to ChatGPT to maybe get a second opinion. And Google has obviously been working on this MedPalm and MedPalm 2. I think for many people, it's going to be easier to digest this idea if the model that talks to them is like fully runs on their computer, open source, no internet, like no data sharing. I think that's a very important piece of this as well. And it's great to see that we're now getting like some cool comparison, but definitely open source is coming strong on this one.
yeah.
Yeah,
Yeah,
I had the same thing as Tanishq with the llama models. You can train them on good medical data, but they don't have they don't perform great at the base. I'll say it's still GPT-4 is king when it comes to it, and the product I worked on last year in March, it's still going. Like Dr. Gupta.ai is still going. It's just a very well prompt engineered doctor with a good RAG system too. That was one of the first. But I will say the thing about the main concern now, and why I think open source will basically completely dominate medical AI, is that their main concern is if they're dependent on some kind of API endpoint, that makes the hospital and people's medical data really vulnerable to malware and foreign intelligence groups, which have been wreaking havoc with medical data and ransomware. So that's their main concern. And the only way we're going to solve that is by having models that they run locally. So I'm really glad Tanishq actually took the task on benchmarking some of these, because you have the entire medical safety field and all the funding and all the people. And I have yet to meet an AI safety person that even knows how to rename a file in Linux, let alone actually write some kind of benchmark. So I'm glad someone's actually taken on the challenge of making open medical LLM benchmarks.
Yeah, I completely agree in terms of, I definitely think open source is definitely the future for medical AI and medical LLMs. And I think hospitals and doctors will be more comfortable when they know they have access to the model and this is the model that they're using, rather than when it's behind some API also, where not only like in the case of like malware, things like this, but OpenAI AI will just change the model or something like this too. These are all concerns that we see this already happening with the models that OpenAI has. And these are all like concerns that there needs to be complete transparency when working with these kind of more crucial applications. And by doing all this open source, I think that provides that transparency that doctors and hospitals and healthcare systems will be comfortable with that. But that's why I'm really excited about working in this area. And I think there's really a lot of potential here.
Incredible. Thank you for this work, Tanishq. Thank you for bringing us kind of the idea of which of the models, surprisingly, Quen. Like I wouldn't assume, if you gave me all the models that we've talked about, I wouldn't assume that Quen was the most performing, but hey, we'll take what we can get. Quen 72B, the best open source doctor, folks. You heard it here based on this research.
Yep. Thank you for letting me share all this work.
That's incredible. And as a friend behind the scenes, but now friend of the pod, Tanishq, you're always welcome. Thank you for the deep dive on the Hourglass Diffusion Transformers. Thank you for the authors as well. Alex, like still, I think is in the audience, and Catherine and Enrico and some other folks. And definitely for MedArc, keep us up to date. We'll keep reporting, and the stage is yours whenever you want it. I think, folks, we're moving forward. I think, Nistan, unless you have, sorry, Tanishq, you have the one last thing you want to.
I was just saying, please follow all of our Hourglass Diffusion authors. They all deserve your support, and also please follow MedArc as well.
100% worth following, and definitely will be in the show notes for folks who are listening to this while driving and cannot like click that follow button. I think we're moving to, as we're in the hour and a half into the space, let me reset this a little bit for folks. If you just recently joined us, you're listening to ThursdAI, where we talk about everything incredible and interesting in the world of AI and open source, LLMs, big companies we cover, and we also had a deep dive today about vision and video. My name is Alex Volkov. I'm with Weights and Biases. I'm an AI evangelist. And yeah, we're here every week and we keep up to date so you don't have to. So if you we're out of Twitter, or if you don't even participate in Twitter and you're just listening to this on a podcast, we got you. We're going to cover everything that's most important and then send you this. So definitely check out ThursdAI.news for that. And I think we're moving towards the big companies area, which we haven't touched. We briefly covered in the breaking news where Hugging Face just announced a partnership with Google, so you'd be able to very easily run the models from Hugging Face on TPUs and I think recently also GPUs, which is incredible because Google has those, but they don't even give them away. I think they're all reserved for collab or something. But also, everything that I have today in the big company LLMs and APIs and everything is from Google. So the next thing that we want to talk about is Lumiere. And I don't know if you guys saw the video, but I definitely saw the video. I think, Pharrell, you sent this in our group chat first, but by that time, there was already spreading around. So there's obviously the whole area that we've talked about. Stable Diffusion video releases like very short videos, image to video and text to video. And then there's the front runners in the closed source, which is Runway and Pika. And there's like another one, Firework. Oh, Leonardo is doing some incredible things. All of them have very short videos. And the consistency between the frames is not like incredible. And Lumiere has shown a video, and like Pharrell, sorry, you're saying this could be like very cherry picked, etc. But it feels like this is like another step in this direction that's significant. And for folks who are not like watched the video yet, definitely worth watching. I'm gonna add this; it's already on the top of the space. But basically, you see they announced a bunch of stuff that Lumiere can do besides just generation. So video in painting is one that they've announced. They announced like a text to video, image to video in painting, and they have something like they say realistic, diverse, and coherent motion, specifically around the motion of kind of the characters, which has been lacking in all these like video synthesis. I will say it's pretty remarkable to even discuss that. Oh, this vision text to video image is not as good as that one. It's really incredible that we're like at this point where we can say a highbrow. Oh yeah, I prefer this output. We're typing text and getting a video back. It's ridiculous on the surface of even saying this to us like a year and a half ago that this would even be possible. But with that said, we're moving forward. We're like hedonistic adaptation is a thing. We're getting used to these tools and we're getting them like day to day. And then we're like, okay, yeah, this tool is better. They said the existing video model synthesized distant keyframes followed by temporal super resolution. And then that's probably, it makes it temporal consistency difficult to achieve. Temporal consistency basically says where like characters throughout the video, what they do. And so you've all seen these videos where like the face changes from frame to frame, etc. And this series of videos from Lumiere looks very consistent, like spatially and temporally, like definitely where the characters are in the video, but also like throughout time. And they attribute this to different like methods that they've used. I will not go into this, but I think the tasks are very interesting. They have video editing applications, image to video in painting, and stylized generation, something I also liked. You'd be able to take like an image and then generate videos based on that style, not necessarily that image. So very impressive from folks from Google. As always from Google, I haven't played with this. I don't think there's a way for us to play with this yet. So there's a paper. Maybe some of the ideas in the paper could be reproduced in open source, but it's like a model show in the paper from folks, quite a lot of folks. Omer Bartal, Hila, Omer, Charles, Herman, and there's like a bunch of folks there on the paper. Very like visually appealing demo as well. So definitely we'll add this video in the show notes. And I think we have one more thing here in diffusion stuff. Yes, the one last thing that I wanted to talk about is Instant ID, so we moved off from Lumiere. Lumiere is like super, super cool, but we haven't seen this work. Hopefully they release this, as Google has they have an example of like when they release stuff, like Dream Booth was released and everybody was using this. And I think that's pretty much it in the big companies on open source. The other thing that I wanted to mention is Instant ID. We've mentioned this briefly before, but it's been pretty much everywhere on my timeline. If you haven't played with this, I very strongly encourage you to play with this, because Instant ID is a technique to create diffusion models with your face. And we've all probably tried this at once with, like I said, like a Dream Booth from Nathaniel Ruiz, who's a dear friend of the pod, who's been here a couple of times. There's like other techniques also to transfer your face into a latent diffusion model. And they all used to take multiple images of your face and some amount of training. And Instant ID is basically a technique that you can try right now, super quick. With 0 shot, 1 image, you can generate images with your face or with your kid's face or whatever. And literally, I just want to highlight how impressively fast we're moving towards these type of tools. This used to take fine-tuning. This used to take GPU and knowledge, and there's like Kohya, and like this used to take LoRa's, and before LoRa's Dream Booths. So actually, there's a couple of companies that I know that built on top of providing the fine-tuning experience around this, where you upload images, you get like this huge like 4 gigabit like stable diffusion file specifically trained on you as a concept. And now there's like a zero-shot transfer thing called Instant ID, where a Hugging Face demo is included here. I will attach this now soon, where you just upload one image of yourself. Literally, for me and Nista and Tanishq, for the non-anons here on stage, we'd be able to use our profile picture here and just generate us with a cowboy hat in noir style, and it will look like us for most of the time. I've tested this Instant ID on my kids, and I'm not going to post this because privacy, but my kid loved it incredibly so much. He was a Superman. It looked like him. It's unbelievable that it was like able to transfer this with one image. It's quite incredible how fast we moved. Here, definitely, if you haven't tried Instant ID, but you have tried avatars before, try Instant ID, you'll be blown away. It runs on your Mac as well. Not that great, but it runs through a Pinocchio computer. Definitely worth noticing how fast we're moving in this generation. And shout out to whoever built this. And there's quite a few technologies like this now, highlighting how fast we're moving. And I think that's pretty much it. So we've covered Art Diffusion. We've covered, let's move to voice and audio. Nistan, you brought us this news, so I definitely want you to pull up the tweet and let's talk about the faster encoder ASR. And then we can also, while maybe you pull this up, I will say that this week, 11 Labs announced like a big funding rise, but 11 Labs also released their dubbing studio. And if you followed Twitter at all, not even AI Twitter for the past like week and a half, 2 weeks, you maybe have seen the dubbed video of the Argentinian prime minister or I don't know if he's a prime minister or president, probably president, right? Yeah, President Milei something. He went to the World Economic Forum and gave a speech in Spanish, and then there was a dubbed version, as like these meetings of global summits of leaders, etc. They have instant translation in their ear to any language, and that's a human that knows both languages. And then somebody said, hey, okay, this is one example, and they posted a HeyGen. If you remember HeyGen, we've talked about HeyGen, quite incredibly translation, dubbing, and lip modulation service where you can upload yourself and get an instant avatar. Somebody used HeyGen on the whole speech, and that went ridiculously viral. I think there was like 50 million views on it on X, and that was like mostly a combination of Milei being like very viral in his opinions, being like stoking some controversy, but also because you literally hear the person speak in English with a Spanish accent, where this didn't happen. Like literally he spoke in Spanish. Quite incredible technology, and people have been shocked and said, oh my God, this is coming for all of us in deepfakes. Fine, we've talked about this multiple times. So 11 Labs now has like a alternative to this called 11 Labs Dubbing Studio. And I've actually used this on a piece of, like on a trailer for ThursdAI of me speaking in English, and I asked it to dub me in Russian, language that I do speak, and mother tongue from Ukraine, and it sounded ridiculously cool. Here's a quick snippet of me from a ThursdAI show we did 3 weeks ago that I dubbed into Russian for your entertainment.
Идеальный гаджет для детей, для родителей, у которых есть дети, которым они не хотят покупать айфоны. Потому что тогда Инстаграм будет разрушать их мозг. Это идеальное устройство для этого. Это похоже на язык. На самом деле вы можете говорить с кроликом, он очень милый, есть один простой интерфейс, это голос.
It sounded like, so far, how should I say, these models that emulate voice did not work on me. Specifically, my accent is not that great, but because my accent is probably Russian, the Russian version of me sounded really close to me. For the first time, I was like, oh, okay, all right. And the 11 Labs now released this dubbing studio, and hopefully these models are now coming to open source. Because there's also a thing where I think there's a recording of Biden saying something like stay home, going around, and everybody in the media making a big fuss about, oh my God, AI is coming for all of us. And there's a big cry for folks to say, we should build tools to detect against this, etc. And my stance remains the same. I think we've talked about this multiple times. The only way through these woods is for everybody to know that their voice is very easily be fakeable with 3 seconds or 10 seconds of their voice. It's time for humanity to adapt to the situation where there's no panacea here. You should just know that just trusting voice blindly without knowing the source just don't do that because it might as well be fake. I don't know if you want to add
Also-
anything. Yeah, go ahead.
Really quick, I want to say we already have laws to deal with this. More law is not necessarily gonna fix the issue because fraud is illegal in a free market. And if you want, or at least people that are more in politics and stuff, if you want to solve the issue, do the job you already have. You already have a list of spam callers which you have been identified without an AI. And can you shut them down?
Yeah.
So people love to imagine problems and love to think of doom or whatever in the future, and then they completely ignore the stuff in front of them. All of us do this. But yeah, again, fraud is illegal. Can you shut it down as a job, as a government? You don't need a new law. You don't need to make speeches about AI. You just need to shut down fraud when it's identified. Otherwise, all of these tools and conferences and stuff are pointless.
As
yeah.
predicted.
That's what I'm gonna say.
Yeah, no,
to
that's
that.
great. As predicted, the first election-related deepfake type thing, the media was all over this, and the doomers were like, "Here we go," and people were like, "It came sooner than we thought." And no, we've literally been talking about this for the past year. That like elections are coming, these things are going to happen. The technology was there even before. Now it's just like a little bit more accessible. The laws are in place. Make it more difficult for grandmas to get spam calls, not make it difficult for the open source stuff. So hopefully, like the more prevalent these technologies are, this is my stance, the better the chance that people will just get used to this being everywhere. And definitely for folks of us who have our audio out there, we're doomed, right? So come up, like my usual suggestion here is come up with your loved ones with a key phrase that only you to know, like the Terminator scene with the dog. Come up with this and make sure that if you get a call in 3 a.m. at night, it sounds like a bad quality version of you, of your like relative from somewhere, from an unknown phone. Make sure it's them by asking like, "Hey, remember we went to Hawaii and you never went to Hawaii?" And they say, "Oh yeah, of course." But also you can probably, most of those will be LLMs, so you can probably like prompt trick them the spammy LLM calls that sound like your relative. All right, moving forward, unless Nisa, you want to add some stuff about this W2V BERT speech encoder. I've added it to the top of the space.
Yeah, just really quick. I'm gonna do the paper reading on it because
Oh hell yeah.
it's a pretty nice paper. So stay tuned from that at some point when we announce it. And it's from MIT's and Google and some people from Google. So it's another really nice encoder only. It has potential, it seems, to be up to 30 times faster. So this
Than
could be
Whisper, right?
quite useful. It could be quite useful for those making assistants that run on local devices or on low resource devices, but also for stuff on the web. Now it is officially supported by the Transformers library. We'll wait on Zenova to, I think probably it's going to be available via WebGPU and stuff, I'm guessing. Yeah, it's nice to see that field also going forward because we already have excellent speech recognition. We know it works really well. We just needed to work on more low power devices and mobile and stuff.
Absolutely. And it looks like some stats here. A bunch of languages are more than the standard Whisper, 143 languages. And you can like fine tune this on specific languages as well to make it like better and benchmark it on Mongolian and beat Whisper in less than 1200 steps. So smaller model, like fine tunable, super, super cool. And the best part of it is MIT license. So there have been other ASRs. They're not in this license. And now we're getting like a state of the art tiny model in this license. I think that's most of the stuff that I wanted to cover. No, I wanted to cover one last thing. National Artificial Intelligence Research Resource, NAIRR, which is coming to us from National Science Foundation, United States National Science Foundation, collaborating with agencies and different, so all of these incredible three-letter agencies are collaborations in this foundation now. NSF is the Science Foundation, but also DARPA and NASA and NIST, which is the Institute of Standards and Technology, and DOD and DOE and like all these things. But also the private sector is joining this. Companies like Anthropic and OpenAI and Palantir and Google and Eleuther and Hugging Face and Weights and Biases, obviously, I saw this. Oh, that's cool. We're like Weights and Biases participating in this incredible effort, are all joining together in this initiative to promote support AI research and advancing like safe and secure and trustworthy AI. And it's also great to see like folks like Hugging Face here, and Meta as well is represented, folks who push open source as well, because these government affiliations, government organizations, they have to have folks who promote open source as well. And they organize into 4 focus areas. Open, enable AI research to access into diverse AI resources via the NAIRR pilot portal. So definitely expect there to be government grants for GPUs for different things. I don't know how easily those would be obtainable. But we had some folks in Canada, from Canada before, talked about you could ask for grants to train or fine-tune, like the stuff that Tanishq was talking about, research which open source is better medical in QA could be happening through the government. They also focus on security and I think something called NARR Classroom, which I have no idea. Oh, reach new communities through education, training, and user support. Like very government like approached. However, this is definitely like good to see the companies that participate in this. It's not only government, it's also open, like a private sector as well. NVIDIA is there, AMD is there, Luther, like we said, open source folks are represented as well. A huge kind of chunk of companies. It's good to see that the government is like actually moving towards some standardization, which may be needed. Hopefully less regulation, more standardization. And I think with that, we are pretty much all over the news that we had for this week, which was great. I want to say thank you. A huge thank you again for, first of all, the listeners who come here and listen, and the folks on stage who help me from week to bring you the latest and greatest in the AI news. Thank you so much, and we'll let you go on this Thursday, and we'll see you next week. Thank you, everyone. Bye-bye.